Hello, this is Dr. Nunez. Welcome to the Chapter 19 problem solving session. So we're going to talk about support department cost allocation and joint cost allocation. Let's get started with support department cost allocation first. Basic exercise 19-1. So all we're going to do here is allocate the support department costs, right? Or determine the percentage that should be allocated to the support department costs. So we've got A and B, and for some reason B is not showing up here, but we need to determine the percentage of the janitorial costs that should be allocated to assembly and the percentage of the security costs that should be allocated to cutting. So we've got, in this case, two production departments, assembly and cutting. And we have two support departments. We have janitorial and security. And those two support departments provide services to the production departments, assembly and cutting. And we are going to allocate, at some point, we're going to allocate the costs to those two departments from janitorial and security to cutting and assembly based on the square footage for janitorial and the asset value for security. And we're given that information, right? The assembly department has 46,400 square feet, $60,000 in assets. Cutting department has 33,600 square feet and $140,000 in assets. So we need to use that information to determine the percentage of costs that would be allocated to the two departments. So I'm going to lay all this out in a nice little table so that we can have a better understanding of what these departments look like. So if I can here, so bear with me while I try to find, I think I figured out how to at least paste from an Excel document with a little bit less difficulty. There we go. So here's what we have, right? Here's what we were told initially. The cutting department uses 33,600 square feet, and it has $140,000 in assets. And the assembly department uses, in this case, 46,400 square feet, and it has $60,000 in assets. So all I did was lay out what we were given in a nice little table so we understand janitorial is allocated based on square footage, right? And cutting uses 33,600, assembly uses 46,400. And then security uses the asset values. And all we want to know is the percentage of cost. We don't actually have the cost. They didn't give us that. If we had the costs, well, then we could allocate. We just need to determine the percentage of costs that should be allocated to these production departments based on how they're using the cost driver, right? The allocation basis, the square footage, and the asset value. So I've got that set up in another table. If I can paste that in, that might help a little bit. There we go. Let's paste it in. There we go. So here it is. So given that information that they gave us, the square footage and the asset value. So the cost from the janitorial department, right? When we allocate to production, to cutting, and to assembly. So again, the service departments are here, janitorial and security, and we're going to allocate to the two production departments. When we use square feet, then the allocation to cutting will be 42%. Because the square footage, right, is 33,600 for cutting out of 80,000 total. 33,006 divided by 80,000 is 42%. 46,400 divided by 80,000 is 58%. So if we had the cost, we just multiply the actual cost times the actual cost times the percentage, right? So the amount of the janitorial cost that would go to assembly in this case would be 58%, right? The amount of the security cost that would go to cutting would be 70% based on asset value. 140 divided by 200, right, is 70%. 60 divided by 200 is 30%. And the reason why I have these numbers highlighted, right, the 70% and the 58%, because technically that's what they're asking us. So for A, an example, the percentage of janitorial costs that should be allocated to assembly. So that is the percentage of janitorial costs, right? If we highlight that, the percentage of janitorial costs that would be allocated to assembly is 58%. So that's part A, right? And the percentage of security costs, that's B, that would be allocated to cutting is the 70%, right? I put the whole table here so that we could see the entire allocation, but all we're really asked about is the 58% and the 70%. Again, all we're doing is taking the allocation basis, right? The square feet, determining the proportion, and the proportion determines the allocation of the cost. Okay, and we don't actually have to do the allocation. We just have to determine the proportions. Let's we will have a few exercises where we actually have to allocate the cost. This one is just kind of an introductory exercise. Let's switch gears now and talk about physical units, the joint cost allocation based on physical units. So when we allocate these joint costs, we've got, in this case, a process that produces two types of products, right? It's a blacksmith company, and the process yields swords, right? They have a decorative sword and they have a broadsword, and they also have a long sword. So, no, I'm sorry. So the process yields two types of swords, a broadsword and a long sword. So there are two products. One is the broadsword and two is the long sword. So they're both decorative swords, right? That's how they describe them, but they're two kinds of decorative swords. It's a joint process, which means they incur all these costs to make these two products. So one batch costs them $4,000. And that one batch yields two products, the broadswords, 30 of them, and the long swords, 20 of them. But they don't get the two products until after the split off point. So remember, you have a joint process that yields, in this case, two products, right? You got product one and you got product two. And up until that point, all you have is this $4,000 cost. And now when you get to the split off point where you have two products, you need to figure out how to allocate the $4,000 to the two products. And the $4,000 should be allocated using physical units, the 30 swords and the 20 swords. That's all we're going to do. We're going to allocate using the physical units, or the 30 swords and the 10 swords, the 30 and the 20. So let's set that up. And again, using physical units, that just means that we're going to base the proportion on the 30 and the 20, a total of 50 swords, and the relative proportions for each of those products. So here, hopefully I can get this clipboard to work up correctly, and we'll get this pasted in. And so there it is. So we have a process that cost, in this case, $4,000, right? That's that $4,000 in that little graph I drew there. That $4,000 cost in the joint process. And the process yields two products, a broad sword and a long sword. And the relative quantities, right? We get 30 of the broad ones and 20 of the long ones. So we got 30 and 20, all for a total of 50. and the proportions, right? 30 divided by 50. That's what that is. 30 divided by 50 is 60%. And 20 divided by 50, well, 20 divided by 50 is 40%. Those are the proportions. And the cost again is 4,000. That's how we're going to allocate that 4,000. 60% times 4,000 is 2,400. That's what we're going to allocate of the joint process cost to the broadswords. And 40% of the 4,000, we're going to allocate $1,600 of the joint process costs to the longswords. And that's how the $4,000 gets allocated. That is the physical units method of joint cost allocation. All we're doing is allocating based on the physical units. Okay, that's pretty straightforward. The physical units method is the easiest method to use, the easiest and the most straightforward. The weighted average method is just a little bit more complicated. The approach is the same. We're going to do the same kind of thing, find the relative proportions, but the proportions are weighted differently than with the physical units allocation. So in this case, we have two products again, right? So we have these this molding process that produces 500 of the red oak casings and 250 of the walnut casings. At the split off point, that's what they get. So essentially, we've got this process, right? This joint process that cost us $7,200, right? That's a $7,200 cost in this joint process. And what it gives us is two products, right? At the end of this process, at this split off point, we end up with the red oak casing and the walnut casing, R&W for red oak and walnut. And we need to allocate the $7,200 to these two products based on some weighted average. Well, the weighted average method, this company allocates based on the weighted average. And the assumption here is that the weighted average should be based on the cooling time of the two products, based on the cooling time. And what we know here about the cooling time is that the red oak casings require twice as much cooling time as the walnut casings. So the red oak requires twice as much, right? The red oak requires twice as much cooling time as the walnut casing, right? That's what this tells us, the cooling time. That's our weighted average is going to be based on that. Twice as much cooling time for the red oak as the walnut. So all we're going to do is set this up so that we use the 2 and the 1 as the weights for those two products. So let me see if I can, again, copy this in, given this this joint process, and we'll get this set up. Okay, so here's our joint cost allocation. So again, we've a joint process that cost us $7,500. And this process yields two products, right? $7,200 cost that yields the red oak and the walnut. And the quantities are given, 500 red, 250 walnut. So 500 and 250. And the cooling time, the red oak takes twice as much time to as the walnut. It's a 2-to-1 ratio. So that's the weight that we're going to use. 500 times 2 gives us a weighted quantity of 1,000. 250 times 1 gives us a weighted quantity of 1. The total is 1,250. Those are the proportions that we're going to use. 1,000 divided by 1,250, right, is 80%. 250 divided by 1,250 is 20%, times our joint cost. That's our allocation. To red oak, 57.60. Allocation to walnut, 14.40. Total cost is allocated in that way, $7,200. That's a joint cost allocation based on the weighted average approach, right? Weighted average. So it's like the physical units, only we're taking those physical units and we're multiplying by some appropriate weight. And the weight has to be given, and it's usually given in this way, right? One requires twice as much time as the other. It's just a 2-to-1 ratio. So we've looked at allocating joint costs based on physical units. We've looked at allocating joint costs based on the weighted average approach. And the third method that we look at in this chapter is allocating joint costs based on the market value at split off. That's the next thing we're going to look at. So in basic exercise 19.5, market value at split off. So again, we've got two products. And these two products, right? Two products. We've got this joint process that generates these two products. And the two products that we're faced with here are the standard product and the curved product. And I'm gonna just switch to typewriter mode because it's just easier for me. So we have this, this joint process, right? Right, that has a cost that is exactly $29,000 a batch. That's what it costs. It costs $29,000 a batch. And a batch yields two products, the standard and the curved, right? Two products. And we need to use the market value at split off. So this batch, $29,000 a batch yields 2,000 of the standard, and it yields 1,000 of the curved. And what we also know here is that we could sell these at the split off point for price. We could sell these for $4, right? $4 each. But the curved, well, the price of these would only be sold at $2 each. That's what we know. That's everything that we're given. We've got this joint process that costs $29,000, yields two products, a standard product and a curved product. We get 2,000 standard, we can sell them for $4 each. We get 1,000 curved, we could sell those for $2 each. And we're going to allocate the joint costs to these two products based on the market value at split off. So we need to figure out what that market value is. And market value is just the quantity times the price, right? The quantity times the price, and find the proportions and multiply times the cost. So the allocation here, let's get the allocation based on what I have in this little representation here. So our that is obviously not what I want. This is what I want. So again, looking at this nice little picture here, we've got a joint cost of $29,000. We've got two products that are generated in this joint process, the standard and the curved, the quantities, the 2,000, the 1,000, and the selling price, the $4 and the $2. So the quantity times the price gives us the total market value. That's what we're going to use to base our allocation on. So the standard product would yield a market value of 8,000, 2,000 units at $4. The curved is 1,000 units at $2, 2,000. So the total market value is 10,000. So 8,000 divided by 10 is 80%, right? 8,000 divided by 10. 2,000 divided by 10 is 20%. Just multiply times the joint cost. 80% times 29,000, that's the allocation to the standard product. 20% times 29,000, 5,800 is the allocation to the curve product. Put it all together, that's the allocation of our $29,000 to the two joint products using the market value at split off. So we have seen all three methods so far for joint cost allocation. We've seen the physical units, we've seen the weighted average, and we've seen the market value at split off. Now let's switch gears and go back to support department cost allocation in exercise 19.1. We have three production departments. We've got production department 1, production department 2, and production department 3. And we have one support department. And this support department has costs that total $157,000. We need to allocate those support department costs to the three departments, the three production departments. And we're just going to use the direct method. So we're just going to directly allocate the cost to those departments based on the cost driver that you see listed here. So the allocation is going to be based on the 1,500, the 200, and the 300. That's our allocation of the $157,000. So again, all we're going to do is figure out what the relative percentages are and then use those percentages to multiply times $157,000. So I've got this set up here so that we can see that allocation. And if I can just paste that in, easier said than done. Here it is. There we go. Okay. So again, we have the support department costs that are $157,000. And then we have the cost driver, the 1,500, the 200, and the 300. So support department costs of 157, cost driver, 1,500, 200, and 300. We're going to use that to determine the relative weights. So in this case, the 1,500 divided by 2,000, right, is 75%. The 200 divided by 2,000, 200 divided by 2,000 is 10%. And the 300 divided by 2,000 is 15%. We have the percentages, just multiply the percentages times the cost. So 75% times 157,000, that's the allocation to production 1. 10% times 157,000, 15,700 is the allocation to 2. 15% times 157,000, 23,550 is the allocation to 3. And that is the allocation of that total $157,000 to production department 1, 2, and 3. Now let's use the direct department method again to allocate the support department costs. But now we've got more than one support department. In exercise 19.3, we have 2 support departments. So we have the support departments here, maintenance and janitorial. And then we have the production departments here, cutting and pruning. And we need to allocate these costs, the 7,800 and the 5,000. Those are the costs that need to be allocated to cutting and to pruning. Now, how are we going to allocate those costs? Well, the maintenance and janitorial costs are allocated based on machine hours and number of trees, right? So maintenance is machine hours, and we usually just abbreviate that MH, and janitorial is trees. And the janitorial is going to be allocated based on trees. So let's see. We have here, let me go ahead and kind of spell this out. It might be difficult to understand what T means. But we have the cost. We have the 7,800 and the 5,000 that need to be allocated. And the first thing I'm going to do is I'm going to set up a table that just shows the cost drivers that we're going to use to allocate the costs. So the company estimates that cutting and pruning is typically 20 trees and 60 trees. So for cutting and pruning, right, this here, well, we're typically going to have 20 and 60 trees respectively. And for those two departments, right? That's how many trees we can trace to those two departments. And then the company estimates that the cutting process requires 9 times as many machine hours as the pruning process. 9 times as many machine hours as the pruning process. So I'll show you how we're going to use that information in the table that I'm going to set up. So when we look at these cost drivers or the allocation base for the two departments, let me see if I can. That is not what I want. Okay, so here is what I need. So we have this nice little table here where I try to summarize that information that we're given about these two departments. So again, let's start with the trees because that's the easiest thing to understand first. The company estimates that cutting and pruning will be 20 and 60 trees. So cutting and pruning, cutting is going to use 20 trees, pruning is going to use 60 trees. And that's how we're going to allocate the janitorial costs based on the number of trees, 20 trees and 60 trees. And then we're going to allocate the maintenance based on machine hours. So maintenance is allocated based on machine hours. And all they tell us about the machine hours is that the company estimates that cutting requires 9 times as many machine hours as the pruning process. That's a 9-to-1 ratio. I'm just going to use that information, 9-to-1 ratio. Cutting requires 9 times as many machine hours as pruning. So when we calculate the proportions, it's going to be based on 9-to-1. When we calculate the proportions here, it's going to be based on 20-to-60. And we get our ratios, our percentages based on those numbers. And all we're going to do is we're going to allocate the 7,800 and the 5,000 based on these numbers. We'll get our percentages based on these two numbers. So again, we're told that maintenance is allocated based on machine hours. Janitorial is allocated based on trees. And we're given trees, right? Cutting and pruning is 20 and 60, respectively. 20 and 60. And then it takes 9 times as many hours for the cutting process as it does the pruning process. So we went with that 9-to-1 ratio. So let's do that allocation if we can. Go ahead and allocate those costs. So I've got the allocation here. Hopefully I can get this pasted in. The allocation of our costs here. So again, we have here now maintenance, right, with a 9-to-10 ratio. So 9-to-10, that's how we get our percentages, right? 9 divided by 10 is 90%. 1 divided by 10 is 10%. And we're just going to multiply times the cost, 7,800 for the maintenance department. So 90% times 7,800 is 7,020. That's what we allocate. 10% times 7,800 is 780. That's what we're going to allocate to the pruning department from maintenance. Janitorial, though, is going to be based on trees, right? 20 trees and 60 trees, total 80 trees. 20 divided by 80 is 25%. 60 divided by 80 is 75%. Multiply times the cost. Well, the cost is only $5,000, right? So 25% times 5,000, that's what we're going to allocate. 75% times 5,000, 3,750. That's what we're going to allocate. Okay. Now, one of the things that they do ask us to do here, so there's an extra step here, something that they haven't asked us to do in previous problems. But what they want us to do is to determine, and let me go back and highlight that. They want us to determine the total cost of each department after allocating the support department costs. The total cost of each department after allocating. So what does that mean? Well, these are the costs that we've allocated, but the departments have other costs. Cutting has a cost, right? It's right there. Pruning has a cost. It's right there. And then we have other costs that we're allocating, right? We're allocating some maintenance costs and we're allocating some janitorial costs. So when we look at the cutting department, for example, we got $54,500 of costs in the cutting department here. Those are costs that we incur directly in that department. And then what we're saying is we're going to allocate another 77,020 to the cutting department. And we're going to allocate another 1,250 to the cutting department. So we have, again, direct costs in the cutting department, and then we allocate more costs to cutting. This question is really asking us about the total cost for the cutting department, right? Got to add those three together. And I've got a table where I do that. Now, I'll give that to you in just a minute. Same thing for pruning. I want a total cost. Well, pruning has a cost. It's $11,000. And then we allocate another 780 and we allocate another 3,750, right? That's the total cost of the pruning department. So if we really want to be able to answer the question here, then we need to put all those pieces together. And I've got a little table where I've put those pieces together. All it does is add the costs, right? So all I'm doing is I'm saying, okay, the cutting department has a cost of 54,500 already, right? That's that number. And then I'm just adding in the 7020 and the 1250, right? So the department has a total cost of 72,770. That's all I'm doing here is adding in all the costs, right? The cost that the department incurs plus the cost that we allocate from maintenance right there, plus the cost that we allocate from janitorial, that 1250. All of that gives us a total cost for the department. Same thing for pruning. The pruning department has a cost. It's got $11,000 cost. And then we take that $11,000 and we add to it 780 that we allocate here from maintenance. And then we allocate 3,750 from janitorial. All we're doing is taking the costs that we incur in that department and adding in those allocated costs to get a total cost, right? So we have a total cost for pruning. We have a total cost for cutting. And technically that's really what this problem is asking for. It is asking for the total cost, right? The total cost of each production department after allocating all the support department costs. So we've done that now. That's exercise 19.3. So support department cost allocation using the direct method. Using that direct method. Okay, let's continue with this direct method in exercise 19.5. So in 19.5, we're going to use the direct method to allocate the support department costs. So again, we've got a situation where we have two production departments and we have two support departments. And what we need to do is allocate these two support departments, right? Janitorial and cafeteria, right? We've got one here and one here. And both of these need to be allocated based on these cost drivers, square footage and number of employees. So we're going to allocate the cafeteria, the janitorial department based on square footage. Here's the square footage, right? And we're only allocating to the production departments because we're using the direct method. The direct method just allocates to the production department. So we're going to allocate the square footage. We're going to use the square footage to allocate the janitorial department costs to these two departments. We're going to use the number of employees to allocate the cafeteria department costs to these two departments. So again, here we're going to use square footage for the janitorial department. That's how we're going to allocate those costs. And here we're going to use the number of employees to allocate those cafeteria department costs. And again, because we're using the direct method, we don't care about how much of the square footage is used by janitorial or cafeteria. We don't care about the number of employees that are used by janitorial or cafeteria. We're not using the sequential method or the reciprocal services method. We're using the direct method, which means we directly allocate these two costs to these two departments. That's what we're going to do. So if that's the case, let's go ahead and get that set up, right? Based on the numbers that we see here. Square footage for janitorial and number of employees for the cafeteria department. So the allocation, if I can get that and paste it in here. Let's see here. Here it is. So the janitorial department, again, janitorial is going to be based on square feet, 1,000 and 4,000. There it is. Janitorial, square feet, 1,000 and 4,000. 1,000 divided by the total 5,000 is 20%. 4,000 divided by the total 5,000 is 80%. And the cost? Janitorial has a cost of 310,000. Multiply the percentage times the cost. That's our allocation. The percentage times the cost. That's our allocation. Same thing for cafeteria. We're going to use employees. 30 and 10, 40. 30 divided by 10 is 75%. 10 divided by 40 is 25%. Going to multiply times the cost for cafeteria. So 75% times 169,000, that's the allocation. 25% times 169,000, that's the allocation. So we're using the direct method. We ignore any services that these support departments provide each other, and we just focus on how the support departments service the production departments. And we allocate based on the appropriate cost drivers for those two support departments. Okay, we've done a couple of these support department cost allocations now. Let's go back to joint costs. Let's go back to the joint costs in exercise 19.7. So in exercise 19.7, when we allocate our joint costs, so what we have here is we have three products. So if I could, again, try and draw this out, we've got this joint process. And this joint process yields three products. Right, we get to the end of the process and we've got three things. Right, so again, we have a joint process. And this joint process has a cost. The joint costs are $3,500 per batch. $3,500 per batch. And we end up with three products. We have washed boards, stain boards, and pressure boards. So we have washed boards, we have stain boards, and we have pressure boards. Those are the three products. And until we get to this split off point, we don't have any separable products. But it's when we get to the split off point that we have these three products. And what we end up with is, well, we got 100 of the washed boards, we got 60 of the stain boards, and we got 40 of the pressure boards. That's what we end up with. That's what the joint process gives us, right? That's the quantity or the number of boards. And we're going to use the physical units. Right, we're going to use the physical units to allocate this $3,500 to these three products, and these are the physical units. So all we need is just a nice little table that's set up to give us this allocation of the joint cost based on those physical units. So if I could go ahead and put that in here. It's not what I want. So we have the quantities 100, 60, and 40, right? 100, 60, and 40. Joint costs in this process are 3,500. These are the percentages, right? Total number of boards is 200. 100 plus 60 plus 40 is 200. 100 divided by 200 is 50%. 60 divided by 200 is 30%. 40 divided by 200 is 20%. Multiply times the cost, that's our allocation. So the amount that we allocate of the joint cost to the three products is shown here. That's all we need. That's the joint cost allocation. Okay, so let's continue with joint costs. We got a couple more to do here. So the next one is the market value at split off. Market value at split off. So in this joint process now, again, with the joint process, and in this case, we have three products, right? So we have this process, right, that yields these three products. And the process has a cost associated with it, right? And the process ends up costing $1,700 a batch. So this joint process has joint costs of $1,700. And it yields three products, right? So they're processing sugar, right? And they end up with sugar that is raw. That's this first one. They end up with granulated sugar, and they end up with castor sugar. Those are the three products, three different kinds of sugar. So they put the sugar cane into the process, and they process the sugar cane, and a batch costs them 1,700, and they end up with sugar that is raw, sugar that is granulated, and sugar that is classified as castor sugar. And what we want to be able to do is allocate this joint cost based on the market value at split off, because we could sell the raw sugar for 24 cents a pound. We could sell the granulated sugar for 25 cents a pound. So 24 for the raw sugar, and the granulated and castor can both be sold for 25. Those are the prices that we could sell these three products for after we get to the split off point. And we want to use those prices to determine market value and then allocate the joint cost. So if that's the case, then again, we're going to base the allocation using some relative percentages. So let me see if I can paste this in here. So we have no, that is not the one I need. Let me go to the next one. Here it is. There we go. Okay. So, this is the one I need. Okay. So we have these three products, the raw sugar, the granulated, and the castor. And we need the quantities. So the only thing I didn't put quantities up here, but let me go ahead and make a note of that. I should have done that. I don't know why I didn't. So the quantity, right? The pounds, right? We have 2,500 pounds of the raw. We have 3,600 pounds of the granulated, and we have 2,000 pounds of the castor. Right. So this is what we get at the split off point, and this is what we could sell them for. So the market value is just the quantity times the price, right? The quantity times the price. So that's what I've done here. Take the quantity times the price, and we get total market value. And it's that total market value that we use to determine the percentages. So the total value, 600 plus 900 plus 500 is 2,000. And then the percentages, 600 divided by 2,000 is 30%, multiplied times that joint cost. So the joint cost times the relative percentage gives us the allocation. Going to allocate 510. And then 900 divided by 2,000 is 45%. Times 1,700, we're going to allocate 765. And then lastly, the 500 divided by 2,000 is 25%. We're going to allocate 425. Okay. So let's move on to the last couple are just joint cost allocations, and the next one is physical units. So physical units, and we've got again three products. So you want to make sure you understand the process. You get one process that yields these three products, right? And this is a good example. You've got this this beef that goes into the process, right? That's what it is. It's a beef processing plant. And given this beef processing plant, you got these, it's a joint process. And this joint process, and I can type a lot faster than I can write. So let me switch here to the typewriter mode. The joint process has a joint cost associated with it. And that joint cost, it costs them essentially $1,500 to process, probably whatever it is they receive into their plant. So they've got this cow, if you will, and it costs them $1,500 to process the cow, and they end up with three products. They've got a sirloin, right? That's split off. They get sirloin, they get ribeye, and they get T-bone. Those are the three products. They get sirloin, they get ribeye, and they get the T-bone. And they end up with, the 10 cows give them 99 pounds of the sirloin, 55 pounds of the ribeye, and 66 pounds of the T-bone. And all we're going to do is use the physical units to allocate. We don't care what they can sell them for. All we care about is the physical units to allocate these costs, right? The 99 pounds of sirloin, the 55 pounds of ribeye, and the 66 pounds of T-bone. That's how we're going to allocate the joint costs in this joint process. So our allocation, based on having $1,500 in the joint cost, 99 pounds of sirloin, 55 pounds of ribeye, 66 pounds of T-bone. We got 220 pounds. So 99 divided by 220 is 45%. Has the $1,500 cost. That's our allocation. Right. So this hopefully this is starting to get a little bit easier because we're just doing the same thing for all these exercises, right? Figuring out the relative percentages based on the total, right? Just take the product divided by the total, got the percentage, multiply times the cost. That's really all we're doing. Okay. And then the last one here is just the market value. One more look at the market value at split off. So the market value at split off works a little bit differently because we're not going to use the physical units. We're going to use the market value of those units, of those physical units. So we have, in this case, it's processing of this crude oil, right? So you put into process the crude oil, and you end up with again three separable products. And of these three products, well, you got gasoline, diesel, and you got kerosene. So if I could here, you got a joint cost is $15,800. It's right there. Joint cost of $15,800. And you end up with the again the gas, the diesel, and the kerosene. And we're going to allocate based on the market value at split off. So what we know here is one batch. When we receive the crude oil and we have one batch of crude oil, at the end of this joint process, what we end up with is 3,415 gallons of gasoline and 2,732 gallons of diesel. And finally, 1,366 gallons of kerosene. So the gasoline, the diesel, and the kerosene. And we could sell the gas for $2 a gallon, right? We can sell the diesel for only $1 a gallon. And the kerosene can be sold for $3 a gallon. So we want to use the market value at split off to allocate the 15,800 for a batch of crude oil. So the allocation is based on the market value. The way we get market value is we take the quantity, the gallons of gas times the selling price, right? The gallons of diesel times the selling price, the gallons of kerosene times the selling price. And if I could paste that in here, so the 3,415 times 2, market value is 6,830. The 2,735 times 1, that's the market value, 2,735. The 1,366 times 3, that's the market value. Total market value, we use that to get our percentages. 6,830 divided by 13,663, 50%. 2,735 divided by 13,663, 20%. And lastly, 4,098 divided by 13,663, that's 30%. Multiply times joint cost, we've got the allocation. And that's allocating joint costs using the market value at split off. So I hope that what I've done here gives you what you need to complete the application assignment and the quiz for chapter 20. I'll see you in the next chapter.